Brandon is, I'll stand over here. Brandon is coming to us from Pluralsight. This is your first SuriCon?
Yes.
Welcome. What do you think so far?
It's awesome. Yeah.
Fantastic. You're not just saying that because you're standing up here, right?
No, of course not.
All right, just checking. Okay, Brent, I've got to put my glasses on me. I can read your slides.
There you go.
Principal Security Author at Pluralsight. So Pluralsight, for those of you who don't know, is part of the, it's one of our training partners that we use to have our Suricata 101 class hosted. It's an on-demand basic Suricata class with a lot of great content that was built by us, but we're doing it in partnership with Pluralsight. But this is very different than anything related to our training. This is your talk, so I'm very, very excited to see it. Thanks for being here.
Awesome. Good morning, everyone. I am incredibly honored to be here talking in front of all of you. As she mentioned, this is my first SuriCon, and so far it has been just absolutely fantastic. Thanks. Good? As long as I don't break anything. So as she mentioned, I'm a security author at Pluralsight. I make course content, mostly video courses, some hands-on labs focused on things like incident response and threat hunting. I'm also a part-time member of the Air National Guard, where I've done a lot of security operations with state response and some DoD networks, so a lot of experience in that space. But here I'm today to talk to you about Log4Shell, specifically using Suricata as an incident response tool. So let's dive into that. Now, all of the tools and Docker containers, the commands I'm going to be running are all available via this GitHub page. And I'm going to have this link up at the end of the presentation too, so you don't have to worry about frantically copying that down. But everything that I'm going to be walking through is all going to be available there so that you can walk through these same exact steps and do the emulation yourself. So I'm going to quickly go over, what is Log4j, what is Log4Shell for any of those who didn't work through that nightmare of incidents. I'm going to have a live demo, and hopefully everything will go perfectly. Then we'll talk a little bit about the aftermath, or like what it looks like today, because we've all patched, and there's definitely not anything that's still vulnerable, right? I'm sure. And then let's talk about some solution pieces. So Google puts out a project every year called, or a report every year with their Project Zero, where they analyze 0 days that they've detected. And you can kind of easily see that from 2020 to 2021, they've over doubled the number of 0 days detected. Now, some of that has to do with the fact that we're getting better at detecting these things. But the other piece of this is, we've all moved to be working at home. We've exposed more things to the internet, and it just creates a much broader environment for adversaries to attack and find vulnerabilities in our environments and networks. And so this isn't going away. While I'll be talking about Log4Shell as the use case for this, the same concept applies to other vulnerabilities, and we've seen the same flow take place many, many times. Now, Log4Shell was so impactful because so many people globally use Java for some unknown reason throughout their environments. And Log4j is so incorporated into these projects that it had a very global scale. Now that second piece, the 1 million attack attempts we saw, within 72 hours, that's very common. It takes about 3 days for adversaries to take a POC, a working POC, and get it incorporated into their process flow and start engaging with those techniques and exploiting customers. And so what I would pose the question to you is, how long does it take your incident response team or your organization to respond to an incident when that original POC is published? Because it takes adversaries about 3 days. And so that's kind of the timeline that we have to deal with. And the last piece there, that was about a month after Log4Shell came out, saying about 30% of instances still remain vulnerable. I've got some of my own research at the end that we'll look through to see at least what I found yesterday that may or may not still be vulnerable. So let's take a step back and talk about what is Log4j, at least the original legitimate package that everybody's using. So let's say you are a developer and you've made some bad decisions in your life, and you found that you are now a Java developer. And as part of that, maybe you need to create an application. And so I'm going to use Pluralsight as the example. Please don't try and attack Pluralsight with Log4Shell attempts. My security team will get very angry at me. But I think it works as a good example. Now, as part of this, you have like a login field. And you want to log information, maybe for an admin use case, so that you can test when things are broken, or maybe for a security use case, right? People are submitting things into this public application that you need to go back and test and figure out maybe if somebody's trying to do something malicious. So that's where Log4j comes in. So that's an open source package or library that you can wrap into your Java application, and everybody does this, not just for logging, but for multiple use cases. And so that's how Log4j got kind of incorporated into many, many Java applications. Now, Synopsys does a report every year on the sheer amount of open source that exists in a lot of environments. And so they analyzed over 2,400 code bases this last year, and 97% of those code bases contained open source in some form or fashion. Out of the code in those code bases, 78% of the actual code was open source itself. So this is absolutely incorporated into a lot of projects, and people are using this because you can't build from the ground up from scratch. It's just impossible. Now the critical piece is 88% of those open source projects had no new development in the last 2 years, and 85% had no new development in 4 years or more, which is insane. Now, a lot of these are small libraries or projects, and so they do little tiny functions, so maybe they don't need to be updated. But those are the same packages that adversaries tend to take advantage of and find those vulnerabilities that have gone without being seen for a really long time. Now, to make sure everybody's on the same page, I'm not just talking about incorporating something like SuriCata into your environment. No, we have a library code base that you develop on, and that library has dependencies. Well, unfortunately, those dependencies have their own indirect dependencies, and that chain can go down and down. And so somewhere along that chain, you have some indirect dependency that might have a vulnerability that you didn't even know existed within your environment. Okay, so what is Log4Shell? And shout out to Gossie the dog there. That's the official logo of Log4Shell, created in MS Paint, which I just absolutely love. So let's first talk about what is affected. The presentation yesterday, there was a submission in the URI field with a JNDI malicious string. It could also be maybe the username or password field. It could also be the body of the request, or really anything that you're logging. Anything that the Java application is incorporating in and pulling into Log4j to log can then be exploited with this Log4Shell attack. Now I have to take another step back and just explain this thing called JNDI, or Java Naming and Directory Interface. So this is an API that you can incorporate into Java that allows you to perform a lookup on a database. Okay, so a little more clear, you log in, right? Your username and password hash is going to get compared against a database to determine whether or not that is successful, whether you have an actual account. Or maybe something gets returned via the application, and so it performs that lookup on some database. The key there is that it can be a local database, or it can be a remote database. And so the Log4Shell attack takes advantage of this being a remote database lookup to pull back potentially malicious information. Okay, so now let's look at the actual attack and the steps that are required for this. So we have our adversary in red, obviously, and then we have our defender there. We're hosting a potential application on port 8080. Now, the logical ports that I'm going to use are going to be the same ones that are in the demo, just to make it easy for analysis, but this can be any logical port that you might be hosting something on. So step one, the adversary is going to send a malicious string to the public-facing application via a field that's being logged. Now your application is going to perform an external query, typically over LDAP, but it's also been seen exploited with DNS or RMI, Remote Management Instrumentation, different protocol implementations that allow for that exploit to happen. Now we added another machine there for the adversary, and that's a key piece. The adversary can send the malicious string via one box, but then they can host the LDAP server on a completely different machine. Okay, so we're now up to potentially 2 different endpoints that the adversary is using for the communication. So we're thinking about this from an incident responder's perspective as you go back through and look at the artifacts. Now, the LDAP server is going to respond with not the malicious code and the exploit, but a pointer to a second request. Okay, the adversary wants to get the communication off that initial LDAP communication to something else. So it sends the pointer. Now your application is going to make a second response, typically over HTTPS, so that it's encrypted, to yet maybe a third server. That third server will then respond with the malicious Java class and code information to perform the exploit. Okay, so lots of different components in this, but this is the typical flow for how the Log4Shell attack worked. Couple components before we go into the demo. So this is what a typical encapsulated is not the right word, jumbled up string looks like. So first you have the JNDI initialization. So the logging thing is going to see this and interpret this and say, okay, now I need to execute JNDI code. You have the protocol, in this case LDAP. In most cases we saw LDAP being used. The attacker's infrastructure, so what domain that it was then going to reach out to. And then the bad stuff, or the payload that is the set of instructions. There's another piece there with the payload. In a lot of examples you saw, and we'll look at an example where I'm using base64 encoded payload, but that can be whatever the adversary wants. It could just be the letter C, but as soon as the LDAP server receives the letter C, it knows to translate that into a set of steps or instructions that it can then accomplish. So that's not necessarily an indicator or something that will give you insight into what actually happened. So this looks like an IOC or something that we can go look for within our network traffic. Until you look at something like this, where you can see the J and DI, but this is totally legitimate code that Java will interpret, because Java is a frustrating language, and will execute this code. So I wanted to take just a minute, because the signature writers that wrote hundreds of signatures to detect on the JNDI strings was just amazing and made my life 1,000 times easier. And so if everyone could give just a quick round of applause to the signature writers, that'd be great. Because I could never do that job, but I absolutely use those a lot. Now, the typical attack chain, we saw a lot of scanning and recon take place first. They took the exploit, they automated this into a bot-type format, and scanned the internet. If you were a mature security organization, you could use this scanning to start to detect and hopefully prevent any of this activity from happening before they were able to accomplish their end goals. Then the exploit was delivered, and then your typical actions. You saw PowerShell activity, delivering Cobalt Strike payload, and usually ending up in ransomware. So I have a cat photo. Hopefully the demo will go off perfectly, and we'll try this. Okay, so in this environment, I have two machines. I've got a defender endpoint and I've got an attacker endpoint. So I'm going to first connect into the defender endpoint. Hopefully the internet is going to work too. Lovely. This is why I do live demos, because they always work. I'm going to swap to a different Wi-Fi real quick. Uh-huh. Okay. You know, naturally I test this about 5 times before I present, and then I get up here and, you know, it never works. Okay, as this is loading and building, because it looks like it's going to restart this, what we're going to do is we're going to take a defender's perspective, incident responder's perspective. I'm going to, and I'm super passionate about doing this to really understand how these exploits and how these vulnerabilities are taken advantage of, and how to find different indicators that you might want to employ for detection within your environment. So we're going to set up the defensive infrastructure. We're going to run SuriCata so we can analyze that network traffic. Then we're going to swap over to the attacker's box. We're going to set up the malicious LDAP server. I'm going to set up a netcap listener, and we're going to try to send a malicious string to create a reverse shell. Then we can stop the attack, go back to SuriCata. I typically run TCP dump or something that has full packet capture, so I can analyze that raw packet traffic too. And that gives you a lot more insight than you might gain from a typical just reading through reports or going back through and trying to understand how this has affected other people. I can't tap to answer sing. I'm sorry. All right, I'm going to talk through what's still vulnerable real quick, and then I'll come back to the demo while that's still building. So naturally, nothing is vulnerable still, right? This happened, what, early this year? So there can't possibly be that many things, at least, right? So as of yesterday, there are over 39,000 publicly accessible VMware Horizon servers worldwide. I'm not sure why you would ever need to make your Horizon server worldwide accessible, but you know, here we are. Back in September, there was only about 30,000, so we're actually increasing the number by quite a bit. This is all analysis done on Shodan, so you can back check my math if you want, but a lot. Now, when I looked at VMware vCenter servers, in September, there was about 2,200 VMware servers publicly accessible. Over 1,200 of those were still running vulnerable versions of Log4Shell. Now, that's better because back in June of 21, over 80% of those were still vulnerable. I took a look yesterday, and it went from 2,200 to 3,200 publicly accessible, and 2,000 now vulnerable to Log4Shell. So we're exposing more VMware vCenter servers that are actually still vulnerable to Log4Shell. So the environment space is actually getting a little bit worse. And then Minecraft. So I knew Minecraft was popular, but there's over 316,000 publicly accessible Minecraft servers worldwide, which is just a massive amount. We've grown about 92,000 since September, and over 48,000 of those are vulnerable. Now, most of us work in an enterprise environment, so why Minecraft? Well, most of us have also started working from home, right? And who runs Minecraft servers at home? Well, that's typically our server admins or our network admins, and God forbid if they have administrative credentials on our network, right? So definitely something that maybe we should be concerned with. Now, some other tactics that are worth noting. Back in August, Muddy Water, an Iranian-based threat group, targeted a software called SysAid, which is a IT remote management-based software. So this is Iran targeting Israel, nations attacking nations. It took until August for them to realize that that software had Log4j in it and was vulnerable, which is, again, is just very crazy. And then July, CISA released a report showing continued exploitation for VMware Horizon servers and UAGs with examples of successful exfiltration of data. Okay. Yes, okay, awesome. Let's run through this real quick. So I'm gonna connect into the Defender endpoint. I'm gonna make this a little easier to see. There we go. Okay, so first thing is I'm gonna set up a new screen session. Oh man, the internet is not being friendly. For SuriCata. Helps if I can type. I'm going to use an exclusive rule set where I've extracted out, oh my goodness, and it's early and I can't type and the internet's not working. We'll see if this lab even works. I'm going to log into my lab directory, and then we're going to listen on interface ETH0. Perfect. Okay, I'm going to detach from that session. So SuriCata is now listening on ETH0 with that rule set. I'm going to shift over to the attacker endpoint now. And there's a lot more details in the GitHub and the lab instructions, so please, please take a chance to walk through this yourself. Similar thing, I'm going to set up a couple screen sessions. First for LDAP, I have a Docker container running. I can't talk and type at the same time, sorry. That has the LDAP server already pre-configured. Now this is defanged, so you're not going to be able to take my Log4j LDAP server and use it in a real world environment. Please don't try to do that anyways, but it shouldn't work for you. I'm going to expose two ports, port 1389 for LDAP, and I'm going to expose port 8888 for the other web server. So I talked about the adversary having multiple machines. I'm going to run this all in a single box, but the same theory and process applies. And then my Docker container. Okay, and we can see it listening on both those ports. And then same thing for Netcat. We'll start a listener on port 7777. Now these are very obvious ports. Using obvious ports when doing analysis makes it much easier to detect and kind of realize what is taking place. Adversaries are going to be using common normal ports like 443 to try to blend into your environment. So keep that in mind as you do that translation from emulation and understanding the attack into what's actually happening. Okay, now the command I'm going to run on through the JNDI string is going to be netcat -nv 31.24.10. So I'm going to have it connect back to my attacker's box on that port 77. And then I'm going to give it a command to say execute bin shell. Okay, so this is going to try to execute a reverse shell on the box. This part can get way more advanced and way more obfuscated, but it works as a really clean example. And so we'll base 64 that so we can see our base 64 string. Now, if I were to curl 172.31.24.20 port 8080, that's the defender's box with the purposely vulnerable machine. We can see that it gives me a status code of 400, saying that there's a bad request. The box is still there, it's just not expecting the input that it should, so I know that it's still live. So back to that same curl command, we saw the URI being executed in the presentation yesterday. A lot of examples use the user agent field. I'm actually going to use the X API version field. So this is an extended field of HTTP that can be used for these web requests, and in this case, it's actually being logged. Now, our malicious string is going to be JNDI, LDAP, 172.31.24.10, because I'm going to point it back to the LDAP server, and then the bad stuff. Oh, now I can't even see what's being typed. That's all right. No mistakes. And I'm going to copy the base 64 string. And send hello world. Hopefully. And then if we, wait, reattach to netcat, connection received. I've got a reverse shell. Now you can clap. Yay. So now I can do my normal enumeration commands, right? uname-a, who am I? Of course, the administrator built this Java application as root, so I have full root privileges to the box, which is not what you want to see from a defender's perspective. And you can go through that whole step, right? Still kind of good on time. I think I should be fine. OK, so now if I wanted to go back and do some analysis. So that's how the attack works. It's pretty simple. I'm going to go back to the defender endpoint. And it's going to disconnect. There we go. I can stop Suricata. And we can see that it's generated our typical logs. Now, this analysis can be done in EveBox, or I typically do most of my analysis in Elastic, where I can cross-correlate different information. But I want you to see what basic information you can get from Suricata that I'll immediately look for when performing this kind of incident response. So first thing is we can see that if I just cat the fast log and do a line count, we have 8 alerts. So with the signatures, even though a single attack was sent, 8 times it alerted because it's detecting different versions of the exploit. I can then dive into the fast log a little bit easier because this is just going to show that high-level information to give me those quick artifacts that I'm looking for. So doing a less on fast log, we can see emerging threats. Thank you so much. Apache Log4j, RCE, or remote code execution attempts. And if I scroll over to the right, we can see the vulnerable application here is running on port 8080, and this is the attacker machine, 24.10. And all the instances are coming from 24.10. Obviously, I did it, so I know that that's what happened, but those are the artifacts we want to go look for. OK, so the next step is we can look in the eve.json file. Now, I'm going to extract out event type with JQ, because JQ is amazing. And we can see all the different events, but I probably want to see this in a little bit cleaner way. So if you do a sort, unique count, and sort again, All right, we've got some statistics, we've got flow-based logs, we've got those 8 alerts that we looked at, some DNS records, HTTP, and file info. So the next piece is to look at our Eve JSON. Hope that the internet doesn't crash. I'm going to select out event type equal to flow. And then select, please work, source IP equal to 172.31.24.10. What was it? Oh, thank you. Boom. And there we can see those logs. Now, because I'm running short on time, I'm going to kind of fast forward through this next piece. But what I'm going to do here, and the instructions will have you walk through these same pieces, is I can see that there's flow-based information here. So we can start to see how many packets, how many bytes are sent back and forth between these hosts. In this initial communication, there's not a lot. So then I want to look at the HTTP information. Now, even though Suricata alerted on this being a Log4Shell attempt, the HTTP log doesn't contain any of the XAPI header information. So you have to extract that from PCAP or from some other source if you're pulling in that extra metadata. So I look at flow logs. I'm going to look at the protocol-based logs that's there. I'm then going to flip the connection because I want to see what our Java application endpoint communicated out to. Okay, and when we do that, we can see the communications over those additional 3 ports, right? The 1389, the 8888, and the 7777, which is the reverse shell. That gives us all the artifacts that we want to go look for. The last thing I want to show you, because this one's really interesting, is if I cat Eve's JSON. Actually, I'm going to go up. I'm going to change the destination IP to .20, which is our vulnerable application. And then I'm going to change the event type to that file info. What you can see here is where the Java class was actually delivered to our vulnerable application. So that's the Java class code information that included the instructions for it to be able to execute system commands. All right, lots of artifacts. I know that was quick. Real quick, talking through some potential solution things. First piece is monitoring, right? We all have dealt with Suricata, and we know how important it is to do security operations and at least just look. I mean, come on, this is a free tool that people have put in a massive amount of effort into writing these signatures, so maybe use it. Another thing that we can do is block outbound traffic. This is easier said than done, but does our application need to initiate communication outbound? In most instances, no. And so having that flow-based rules and allow lists in place is going to make your environment incredibly more secure. SBOMs are a big buzzword that have happened recently, but getting after the core of what they're trying to do is really understanding what exists inside your environment. What software, and then as you mature that, what dependencies do you rely on that you can start to mature and enrich with additional information so that when the next Log4j or next exploit comes out, you're able to respond much easier. And then as we talk about response, it kind of gets into risk strategy, which is not my favorite thing in the world. But I do think that having some really easy questions that you can ask. So this actually comes from Netflix. This is how they respond to incidents. They ask 5 questions. Is the application internet facing? Is there an active exploit in the wild? Is the vulnerable method able to be executed within our environment? What's the application risk, or how important is that application to our overall function? And then finally, what is the CVSS score? Too many people put way too much emphasis on the CVSS score, and it needs to be incorporated with the other things. And then you can use those answers to determine what the appropriate level of response should be. And finally, because I'm selfish and I think education is the most important, it's education, right? We have these complicated environments, and they're only getting more complicated every day. So having an environment that your operators can get hands-on with experience and understand these exploits and understand different technologies is incredibly important, because we no longer live in a world where we control all the servers and there's one single firewall. No, we've got cloud-based infrastructure, virtualization, containers, serverless architecture. It's complicated. So how do you maintain those skills within your team? I think I might have gone a little over, but that puts me to the end. Again, super honored to be here. Thank you all so much. My contact info is there, and there's again the GitHub link for the lab stuff. So thank you.
So thank you. Does it work? Yeah. So thank you. This was really interesting. So one quick remark for everyone. If you want to log the X API version field, you can do a custom HTTP header logging with Suricata. There is this custom field in suricata.yaml. So if there are header fields that are of interest to you for this kind of cases, please do. And so maybe more for you. Can we have the pickup of the demo? That will be really interesting to keep this pickup for future tests and that kind of stuff.
Yeah, the lab is going to walk you through doing both Suricata and TCP dumps, so you get the full PCAP, and to do that analysis, so you get to see full PCAP piece. That's a good idea, though. I'll upload the PCAP to the GitHub page later this week, probably. That way everybody can see the full analysis.
Perfect. Thank you.
Thank you for your talk. It was really interesting. Like many here, probably during the weekend that Log4j became quite critical, because it's always a weekend for some reason.
And Christmas.
And Christmas. And the Formula One final was that weekend as well, if you remember. But what we noticed is that we initially wrote rules for the exploitation attempts to mine IOCs out of it directly, like you discussed. But everyone and their mother was scanning for it, so that quickly became infeasible. And then we moved to rules that triggered on Rogue, LDAP, and Jeremy to the external net, which I didn't see in the alerts overview. Are those rules ET Pro, or because I remember them being there? We also wrote them ourselves, but are they in current rule sets?
I don't know.
I think they had released those to the public, if I remember correctly. I think that was one of those. ET's pretty good about when something big hits, not just putting them in the pro rule set, but actually giving them to everyone. Yeah, which was huge, because we didn't have pro, but we still got access to all the Log4Shell signatures. We did the same thing where we wrote, okay, any of our applications that were communicating outbound over LDAP or similar ports to alert on. So I don't know if that was one that was added in. But I do know that like initially within about 2 weeks, there was 20-some active rules with about 100 written. The rest of them were commented out. And today there's about 110-ish active rules for this. So the team has put in a lot of effort into making those. So.
Cool. Thank you.
Yeah. Thank you all so much.